Section 3.3, Differentiation Rules. These notes are from OpenStax Calculus Volume 1. At the bottom of every page, there is a link to the textbook, somewhere around here. And I highly suggest you go there because these notes and these videos are intended to go along with the textbook, so they go very well together. All right, so please do that at some point if you haven't already. All right, so our first differentiation rule. Actually, before we get there, I just want to say I'm sorry, okay, because, you have to be exposed to where those rules are coming from. It's really an important process of becoming a mathematician, and that's what you are. You're studying math. So, the how-to, the limiting process, I think I said several times, the limiting process is the most important, most valuable part of all of calculus. So we use limits for everything in the last couple sections. Well, in this section, we are going to not prove things. We are going to use some rules, and these are really observations. If you use the limit definition over and over again, you'll notice some patterns if you haven't already. And so these rules are the patterns. So you're going to go, why didn't you talk about this before? Why didn't you show me this first? But the fact is you have to know where it comes from to appreciate where you're going and the limiting process that is calculus. So our first rule is constants. Let f of x equals c, where c is a constant. Then f prime of x is 0. Okay, so think of it this way. Lines, no x's, just constant horizontal lines. The slope is always 0. That's what this is. It is a horizontal line, and so therefore its slope is 0. So find the derivative of f of x equals 8. Well, the slope of that is f prime of x equals 0. And if you do apply the limit definition, you will get 0. We're not going to dwell on that one too much longer. The power rule is a really valuable rule. Let f of x equal x to the n, where n is an integer. Then f prime of x equals n times x to the n minus 1. Or, said another way, d dx of x to the n equals nx to the n minus 1. All right, so let's look at example 2. Find d dx, the derivative of the function x cubed. By this rule, here our n is 3. All right, so our n is 3. So our derivative is 3x to the 3 minus 1, or 2. So our derivative function is 3x squared. That's all there is to that one. Example 3, differentiate x to the 10. Well, the derivative of that is going to be 10x to the n minus 1, so that'll be 10x to the 9. Go back in the last section and look at those quadratic functions and see if you can make sense of those a lot quicker now. The derivative of x to the 7 is 7x to the 6. We reduce the exponent by 1, and we multiply by the old exponent. Example 5, find the derivative of g of x equals 3x squared. So g prime of x, that is going to be, if we multiply by 2, that'll be 6x to the first. And compare it to the derivative of f of x equals x squared. So f prime of x is bring down the 2 to x. All right, well, to compare this, we want to notice this. The derivative is 3 times 2x. Well, what do you notice about the original function? It had a 3. Okay, so there's kind of the thing. Since the limit can be applied over sums and differences, and actually constant multiples, as long as those limits exist, the derivative holds as well. So that is, if we have differentiable functions f and g, if we have a sum or a difference, we can take the derivative of them separately, just as we could the limits, and add or subtract those depending on what the original operation was. If we have a constant times our function, then that is the constant times the derivative of that function. All right, so let's look at number 6 here. F prime of x, the derivative of that is, we're going to take the derivative separately. The derivative of this portion right here is 10x to the 4. Our power rule, we ignore the 2, we say 5 times 2, and then make that x to the 4. The derivative of just 7 is 0, so we would say plus 0, or not write it at all in that case. And there is our derivative function. Number 7, the derivative of f of x equals 2x cubed minus 6x squared plus 3. Well, the derivative of this one is 6x squared, decreasing the exponent by 1. The derivative of this is minus 12x to the first, or just x, and then plus 0. And that is our function. Okay, so for our next example, find the equation of the line tangent to the graph f of x equals x squared minus 4x plus 6 at x equals 1. Now, in the last couple of sections, that would have been a big ordeal. But let's go ahead and find f prime of 1. F prime of 1 would be the derivative function evaluated at 1. So I'm going to go ahead and write that like this. That is dy dx evaluated at x equals 1. All right, so dy dx would be 2x minus 4 evaluated at x equals 1, which would be negative 2. Now, I wrote that out in the longest way I could have possible. But that is some of the notation to keep in mind. We're taking that function, evaluating it at x equals 1. The vertical bar means that. So that's the slope. Now, we have a point, 1, comma. If we evaluate that, that's 1 minus 4, negative 3, so that's positive 3. All right. So if we plug that in to our point slope form, that would be y minus 3 equals our slope, x minus 1. Y minus 3 is negative 2x plus 2, and therefore y equals negative 2x plus 5. Things go a lot quicker. So first, find our derivative and evaluate it at that point. Then on to our point slope, which leads us to our slope-intercept form. Right, next we have the product rule. This is if we have two functions that are multiplied. So let f of x and g of x be differentiable functions. Then the derivative of f of x times g of x, this right here, okay, is the derivative of f times g plus f times the derivative of g. Or you can put it in this prime notation. Fg prime is f prime g plus fg prime. So let's go ahead and evaluate that with this first one. For j equals x, j of x equals f of x times g of x. Use the product rule to find j prime of 2. Okay. Well, by this definition, since j is f, all right, so let's go ahead and say, we'll add that here. J prime of 2 is f of 2 times g of 2 prime. By definition, that is going to be the derivative of f, so that's f prime of 2 times g of 2 plus f of 2 times g prime of 2. Okay. Now, I'm really abusing notation with that first bit. That is not quite accurate the way I wrote that. So bear with me. But I'm applying that rule to that. And that would be f prime of 2 is negative 4 times g of 2 is 1 plus f of 2 is 3. G prime of 2 is 6. So that is 14. Right? So j prime of 2 is 14. Now, I'm going to write this another way, that rule. A lot of times you might see it written like this. uv prime equals u prime v plus v prime u. That's just another way that I often see it written with u's and v's. All right, so in this case, we've got, I'm going to go ahead and use that, u and v. we have a product of two functions. So f prime of x is u prime, that would be 2x, times v, 3x cubed minus 5x, plus v prime, that would be 9x squared minus 5. I'm using those other rules. V prime times u, which is x squared plus 2. Now, perhaps we should clean that up just a little bit. That would be 6x to the 4 minus 10x squared plus 9x to the 4, 9x to the 4, okay, and then we've got plus 18x squared minus 5x squared minus 10. So f prime of x was going to be 15x to the 4th, negative 10s, that is 8, plus 3, x squared minus 10. And there is our derivative function based on that product rule. Number 11, let's go ahead and call these u and v. So our f prime of x is derivative of the first one, that'll be 10x to the 4th, times our v, 4x squared plus x, plus v prime, that would be 8x plus 1, times u, 2x to the 5th. So this would be 40x to the 6th. All right, 40x to the 6th plus 10x to the 5th. All right, distributing that, 16x to the 6th plus 2x to the 5th. So that f prime is 56x to the 6th plus 12x to the 5th. All right, so remember, the derivative of the first, and then you add the derivative of the second. All right. All right. One of the last things we're going to have here is the quotient rule. In fact, I believe this is going to be the last rule that we are going to have. Yes, it is. The quotient rule. So rather than having a product of two functions, f of x times g of x, we have f of x divided by g of x. Now, this rule right here, f prime of x times g of x minus g prime of x times f of x divided by f of x squared. That is our rule. Now, the way I remember this, the way I actually learned it, is low d high minus high d low over low low. If that helps, go for it. Hold on to that. Low d high minus high d low over low low. Yodel to yourself. I'm going to go ahead and write this in u-v notation like I did earlier. U divided by v prime is low d high, so v du, derivative of u, minus high d low over low low, v squared. It's a common way to see that. So in our case, this would be u, and this would be v. So 5x squared divided by 4x plus 3. So for our derivative, k prime of x, all right, low d high would be 4x plus 3. Derivative of the numerator there is 10x, so times 10x, minus high d low, so 5x squared. The derivative of the denominator is 4 over the denominator squared. So 4x plus 3 quantity, in parentheses, squared. All right, so that would be 40x squared plus 30x minus 20x squared. Okay, good. Divided by 4x plus 3 squared. I'm going to combine like terms and factor the numerator. All right, if I combine like terms and factor out a 10x, that would be a 20x squared. So 2x plus 3 over 4x plus 3 squared. Okay. Now I'm going to leave that, and the reason I'm factoring that is because later on in this section, and certainly in another chapter or so, being able to find the solutions and the places where that derivative is 0 and where it's undefined are going to be very, very vital. So factor your numerator as much as you can in these cases. Number 13, find the derivative of this function. All right, well, if here is our u and this is our v, then our derivative, k prime of x, low d high, so that is 4x minus 3. Derivative of that is 3. Minus high d low, 3x plus 1. D low is 4 over 4x minus 3 squared. All right, so multiplying that out, I get a 12x minus 9 minus 12x minus 4 over 4x minus 3 squared. So that will be negative 13. Negative 13 over 4x minus 3 squared. All right, next we want to try something a little different. F of x equals x to the negative 4. I want to point out this can be written as 1 over x to the 4. So let's take the derivative of that. If we're going to do that, f prime of x, so that would be my u and my v, low d high, so that would be x to the 4th times 0. Okay, minus high d low, yeah, there we go, minus high d low, so that would be 1 times 4x cubed over low, so that'd be x to the, if we square that, we get an x to the 8. All right, so this is going to be negative 4x cubed over x to the 8, or negative 4 over x to the 5th. Okay, now suppose that rather I did this. I mean, it'd be really nice if the power rule worked, right? That would have made this a little easier. That would have been negative 4x to the negative 5, subtracting 1, which is negative 4 over x to the 5th. And lo and behold, the power rule works. The power rule works for all integers, and in fact for all real numbers. So if you have square roots, it comes in very handy with things like that. So you can use the power rule on something with a negative exponent. Okay, well, let's try a couple that are also negative exponents. Let's write these first as 6x to the negative 2. Well, in that case, that is negative 12x to the negative 3, or negative 12 over x cubed. That is our derivative. So if you see something that is rational like this, it's a really good idea to write them without a rational component to them. Make them where they are x to the something. All right, so that would be f prime of x is negative 7x to the negative 8, or negative 7 over x to the positive 8. Okay. Moving on. For k of x equals 3h of x plus x squared g of x, find k prime of x. All right, this will require us to apply a lot of our rules. So for the first, I have a constant multiple of that. So I'm going to ignore my constant and just say 3 times h prime of x, which I don't know what h prime is. I don't know what h is. So just 3 times h prime of x plus. Now for the second component, I'm going to have to use my product rule. My product rule would say the derivative of the first, so here's my u and v, So I'd take the derivative of the first, that's 2x times g of x plus v prime u, so g prime of x times x squared. And that would be k prime of x. So if you don't know what the functions are, we can still arbitrarily write them as derivatives, g primes and h primes. All right. For k of x equals f of x times g of x times h of x, express k prime in terms of f, g, h, and their derivatives. All right, so let's go ahead and think of this as our u, and these last two as our v function. In that case, we would have derivative of the first, f prime of x, times our v, so g of x, h of x, plus derivative of the second, that would be g prime of x, oh no, I can't do that, it's a product, g of x, h of x prime, times derivative of, or times just the first one, the u, so f of x. Okay, well, I'm going to have to use the product rule again. Let's leave that part. That would be derivative of the first times the second plus the second, so the derivative of the second, so h prime of x, g of x, times h of x, or times f of x there. All right. Oh, not do that. H of x. Okay, so if I distribute the f of x, what I get is this. F prime, I don't know why I keep wanting to do that, f prime of x, g of x, h of x, plus f of x, g prime of x, h of x, plus f of x, g of x, h prime of x. This is the general power rule for three functions. The derivative of the first, leave the other ones alone. The derivative of the second, leave the other two alone. The derivative of the third, leave the others alone. This would work for any number of functions. So remember that in case it comes up. So these rules can actually apply to much bigger things. Find the derivative of h of x is 2x cubed k of x over 3x plus 2. Okay, so we will use our quotient rule here. Here is our u. Here is our v. So h prime of x is low d high, so 3x plus 2. The derivative of u would be a product rule. So that would be, let's see, 6x squared k of x plus k prime of x 2x cubed times 2x cubed. All right, that's low d high minus high d low. 2x cubed k of x d low would be 3 all over low low, 3x plus 2 squared. Okay, now this may not get much prettier here. You know what? I'm just going to leave it this way. I'm sure it will simplify a little bit. I'm not sure that'll be worth it, especially with the space I've got here. All right, number 20. Find the derivative of h of x is x cubed times f of x. This will be our product rule. So the derivative of the first is 3x squared times f of x. There's our u and our v. Plus derivative of the second, f prime of x times x cubed. All right, for the sake of this big idea here, I want to just leave that the way it is. All right, number 21, determine the values of x for which this function has a horizontal tangent line. A horizontal tangent line means we have something like this, where our slope is 0. So let's first find the derivative of this. The derivative of that is 3x squared minus 14x plus 8. We want to know where that is 0. Let's see, does that factor? That would be 24. 7 and 4 will not work. 3 and 8. I'll just go ahead and use the quadratic formula. It'll work. So if I want to solve this, the values of x, for where this is 0, all right, negative b plus or minus the square root of b squared minus 4ac. I believe that's 96. 4ac, so that's 12. Yeah, 96. Over 2a, so that's 6. So that's 14. Oh, that's 100. Square root of that's 10. So plus or minus 10 over 6. So that would be 24. That'd be a value of 4. So this would have factored. And, oh, not quite. 4 and 2/3. So x equals 4 and x equals 2/3 would cause our tangent line to be 0. All right, moving on. Given the position function, what is the initial velocity? Now remember, initial velocity means v of 0, and that means s prime of 0. So let's go ahead and find s prime. S prime of t, well, if we have our u and our v, low d high, t squared plus 1 times 1 minus high d low, t times 2t over low low, t squared plus 1 squared. So that would be 1 over t squared plus 1 squared. Okay. Well, if we evaluate that, so s prime of 0, which is s prime of t evaluated at t equals 0, plugging that in, we get 1 over 1. Well, that's just 1. All right, so s prime of 0, or v of 0, is 1. All right, our last question, I believe, yes, our last one in this section, determine the values of x where this has a horizontal tangent line. So follow the same process we did in the last one. First, take the derivative, so 3x squared minus 14x plus 8. And it looks like we got this one free because that is the same function. All right, so that brings us to the end of our function on our derivative rules. These are going to be very handy and make your life a whole lot easier as opposed to that limit definition. But remember, calculus is all about those limits. That's what it comes down to. That's it.